Okay, in our last lesson we looked at the normal probability distribution, which is this bell-shaped distribution. Notice probabilities are on the vertical axis, and then whatever my value for the random variable x is on the horizontal axis. It could be anything, x could be the heights of all adults in the world, okay? And then there's the probability. We found that most people are average height, very few people extremely tall, very few people extremely short. Okay, there's 6 properties there we need to know. The curve is continuous, no gaps in it. It's bell-shaped, that's just describing that particular shape. It's symmetrical about the mean, very important. It's symmetry. The mean, median, mode are equal and located at the center. The curve is unimodal, meaning it has one mode, and the total area under the curve is equal to 1. Okay, in this class we're going to look at a bit of problem solving on this stuff. Okay, there's something called the empirical rule, first of all, that I want to mention. And the empirical rule says this: for a normal distribution with a mean of mu. Now, mu is the mean of a population. You'll often see x bar used for mean. So my example down here, I use x bar, so maybe I'll just get rid of that for the moment. And a standard deviation of little sigma. Approximately 68% of the observations fall within sigma of the mean. Okay, so that's one standard deviation of the mean. Approximately 95% fall within 2 standard deviations of the mean, and approximately 99.7% fall within 3 standard deviations of the mean. I'm using x bar for the mean here. So this is called the empirical rule. You have to learn that by heart. You have to learn 68%, that's 1 standard deviation, 95%, that's 2 standard deviations, and 99.7%, that's 3 standard deviations. This is sometimes called the 68, 95, 99.7 rule. Okay, but it's usually called the empirical rule. Okay, so we're going to just look at a few things based around a fairly standard question. I'm going to just use these two tools. So this says the mean of a sample is 100 and the standard deviation is 15, and it says suppose these are, the mean and standard deviation of a normal distribution. It's very important that we're talking about a normal distribution. Not all distributions are normal. I want to find this interval here. So a couple of things. This is interval notation. We have a starting value in our interval and our finishing value on our interval. And we have square brackets. So I'm just going to replace these things. X bar we're saying is 100. And little sigma is 15. And then I'm going to get 100 over here plus 15. And what I get here is, and again I'll explain exactly what this means, this is 85 to 150. Okay, so this interval notation means we're starting at 85, it's 115. The square brackets are saying inclusive. So 85 is included in this interval, and so is 115. And it's not just a pair of numbers, this is an interval. This says all numbers from 85 to 150. So mu are the mean, subtract 1 standard deviation up to the mean plus 1 standard deviation, that's 85 to 150. Okay. X bar minus 2 sigma, well, x bar is 100 minus 2 standard deviations, well, that's 2 15s, up to 100 plus 2 standard deviations, which is 2 15s. And what I'd get there is 100 minus 30, that's 70, up to 100 plus 30, that's 130. So we have an interval starting at 70, including all numbers up to 130, and that's an inclusive interval. 70 and 130 are inclusive. So all numbers from 70 to 130 inclusive. That's mean minus 2 standard deviations to mean plus 2 standard deviations. And then finally I'm going to look at this one. The mean minus 3 standard deviations. Well, that's 100 minus 3 15s up to 100 plus 3 15s. And what I'd get there, if I look at that, that's going to be from 55 up to 145. So those are intervals. This is saying all the numbers from 55 to 145 inclusive. This is called interval notation. So we're using interval notation here. And in interval notation, we have brackets, a comma, and we have a starting value on the interval, finishing value on the interval. That is all the numbers in the interval, not just 85 and 115, all the numbers in between. The square brackets are saying they are included numbers in the interval. Okay, so that's just a bit of calculation with these things. You'll see these little things come up quite often in questions when you're given the mean, given the standard deviation. Okay, taking the same distribution, it's a normal distribution with a mean of 100 and a standard deviation of 15. It says sketch the curve of the normal distribution. Well, every normal distribution kind of follows the same curve. I want to sketch it. You know, and they're not looking for absolute artistry, but to get the general kind of idea. It's increasing here with a smiley face, and then it's kind of this sad face section in here, and then it's turning into a smiley face section over here. Never actually turning around though and going up. That's approaching the horizontal. So that's the sketch of the curve. A couple of important details, of course, that I'm going to put in. Right down the middle, that value right in the middle, that's the mean. That's 100. That's 100. And if I take a standard deviation of 15, what the empirical rule says is 68% of the data fall within one standard deviation of the mean. So one standard deviation to the left, well, that's 15 less than 100, which would be 85. And one standard deviation to the right would be 15 more than 100, which is 115. And if I looked at that, you know, what the empirical rule tells me is that 68% of all observations fall within there. So suppose these were measuring IQ scores here. Imagine these are measuring IQ scores. What we're saying is 68% of people in the world have an IQ between 85 and 115. That's the curve of the normal distribution. I could go out to two standard deviations, 15 less than 85, well that's 70. And 15 more than 115, that's 130. And there would be 95% of people have IQs between 70 and 130. I could go out one more standard deviation there to 55 and up here to 145. And what we're saying is that 99.7% of people would have IQs between 55 and 145. Okay, suppose the mean, again, the same distribution, normal distribution, mean of 100, standard deviation of 15. Find the middle 68% of the data. Well, the middle 68% of the data falls within one standard deviation of the mean. Okay, so one standard deviation to the left we said was 85. One standard deviation to the right is 115. So the middle 68% of the data would be the interval from 85 to 115. The middle 95%, well, 95% of data falls within two standard deviations of the mean. I'm going to draw a rough sketch. Two standard deviations from the mean. Well, there's the mean of 100. Two standard deviations would be 2 15s, which is 30. 2 standard deviations to the left of 100 would be 70, 2 to the right would be 130. So 95% of data is in there. The middle 95% of the data fall between 70 and 130. And then finally, to find the middle 99% of that, 99.7% of the data, well, 99.7 fall within 3 standard deviations of the mean. Again, just a rough sketch here. My mean is 100. 3 standard deviations, well, that's 3 15s, which is 45. 45 less than 100 is 55. 45 more than 100 is 145. So that's 99.7% of the data in there. So the middle 95%, so the middle 99.7% of the data is the interval from 55 to 145. Okay, so these are real typical kind of leaving cert questions you get asked at both ordinary and higher level. Okay, so practice those. We look at a few more problem solving type questions in the next class. Again, we're in section 19.1, so practice, practice, practice.